Now, how do we use the input stream? Once connected to a file, the input stream variable can be used to produce input just as you would use with cin with the extraction operator, just like this one. So we declared two variables of type integer, and in this case, we would like to provide input for our variables, one number and another number. As you will notice, instead of using the cin statement, we instead use the if stream variable that we declared, and we still use the same operator. Okay, the same operator that we used with cin. Hence, we now provide the input for the following variables. So whatever is the content of the file that we connected to InStream, that will be received by the following variables. Of course, it is assumed that the file actually contains something, and to be specific, it actually contains integer numbers. On the other hand, how do we use the output stream? An output stream works similarly to the input stream, only that this time it will be used to receive the output of our program, just like this one. Again, we declare a variable of the output file stream data type, then we name our variable properly, and just like the if stream variable, we also need to open the file that we will use for output. So at the same time, what happens here is that instead of using the cout method, we will simply use our offstream variable to write the output of our program. So which means whatever is the result of this output routine will be written into this file instead of our screen. And of course, the files that we use also need proper file names. An external file name is the name for a file that the operating system uses. For example, our input file and output file were used in the previous examples. Of course, these files should exist on our disk in order for it to be read or written by our program. Of course, it also needs to match the naming conventions on your system, although that wouldn't be an issue because of course we can simply use regular file names for our data, for our files, for our data, and it's usually only used in the streams open statement. Once open, it is referred to using the name of the stream connected to it, as we have seen a while ago. So we first need to declare an input file stream to which we will connect our input file, and at the same time we also need to declare an output file stream which is connected to our output file. After using a file, it should be closed. Okay? So this disconnects the stream from the file. So which means after we use a file for input or output, they should be properly closed. And of course, that can also be done in our C++ program. We close files to reduce the chance of a file being corrupted if the program terminates abnormally. And of course, we all know what happens to a file if it gets corrupted. It's either it cannot be read anymore, or if we are able to open it, its contents might be useless since it's already corrupted. And it's also important to close an output file if your program later needs to read input from the output file. And the system will automatically close files if you forget, as long as your program ends normally. So the point is, even if we don't put a routine which will specifically close the files that we use for our I/O, our system will do it for us. But the point is that will only happen if our program ends normally, which means our program reached its exit point and it was able to terminate normally. But what if your program crashed in the middle of its execution? So which means whatever files that were opened will not be closed properly, and that might corrupt the files that we used. Now let's take a look at our first example. Okay, so here's our first example. So as you can see here, we need to include first our I/O stream. So we will be doing a standard I/O routine. And if we will recall, in order for us to use our input file and output file streams to read and write into files, we must need to include the fstream library. And of course, the following are standard stuff. So we need to declare a variable of input file stream, and we also need to declare a variable of output file streams. And as we've mentioned a while ago, we need to connect these stream variables with files. So as you can see here, we call the open function of the instream variable, and this is the file name, okay, of the file that we will use for input. And also, this is the file that we will use for our output. So which means after this program executes, whatever the output of our program is, it will be written into this file, the outfile.dat. So for our program, so let's see what it does. So as you can see here, it will use our file as input. So for the sake of example, we will comment this out and instead use instream for our input, and we will also comment this out because we would like to see everything written into our output file. So we can expect that this output will be written into this file, the outfile.dat. And as you can see here, we closed our files properly. Okay, we simply call the close functions of both the instream and outstream variables. So let's try to run this program. But before anything else, let me show you first the content of our input file. Okay, so here's the content of our input file. Okay, so we have the following numbers, and based on our example, we will add the first 4 numbers from that file. So which means our first 4 numbers will be this 1, 2, 3, 4. So let's see what happens. So let's run this program. Okay, so our program was able to execute and terminate. So let's take a look at the content of our output file. So remember, our output file was outfile.dat. So let's take a look what's inside. Okay, so that's it. So that's the result of using file as an input and using file as an output. And Of course, we were able to close that properly. We now proceed with objects. So if we will recall, the if stream and off stream variables that we used in our previous example are considered as objects. And an object is a variable that has functions and data associated with it. So if you will notice, we were able to call a couple of functions with the if stream and off stream variables that we used in the previous example. In-stream and out-stream each have a function named open associated with them. And in-stream and out-stream use different versions of a function named open. So see, they actually are different from each other, although they have the same names for the functions, but for each of them, they are different. One version of open is for input files, and of course, the other version of open is for output files used for writing our output. Now, talking more about objects, they have what we call member functions. A member function is a function associated with an object. For example, the open function is a member function of instream, as we've seen in the previous example. And we also have another version of an open function, which is this time a member function of outstream. Now let's talk about objects and member function names. First, objects of different types have different member functions. Some of these member functions might have the same name, just like what we have seen with our if stream and off stream objects, in which they both have the open and close functions. Different objects of the same type have the same member functions. And that's what brings us to classes. So talking about object-oriented programming, objects and classes are very important concept that you need to understand for you to get comfortable with the concept of object-oriented programming. So although you will have an entire subject dedicated to that, but of course it's also a good thing that at least we know the fundamental concepts of what objects and classes are. So a type whose variables are objects is called a class. So that's just like what we did here. Okay. So if stream is the type of the in-stream variable object. So we declared this variable which we will use to contain the file which we will use as input. So this is actually an object variable which belongs to the ifstream class. The class of an object determines its member function. So which means we have this class built in C++. And of course, the ifstream class has its own set of functions, or shall we say member functions, which means every time we declare a variable of this type, what happens is that whatever functionalities that this class has is automatically passed down to an instance of this class, which is the in-stream object. Hence, that would determine its member functions. Just like what we have here. Okay? We declare two variables, in-stream1 and in-stream2, both of the ifstream data type, which is, of course, an object. Okay, as you can see here, instream1 open and instream2 open are the same functions but might have different arguments. So which means it's possible that we call the same function but we can provide different arguments to them. So we can provide a different file for instream1 and we can provide a different file for instream2. And of course, talking more about class member functions, member functions of an object are the member functions of its class. So just like our open and close functions, those are member functions of both the ifstream and offstream class. The class determines the member functions of the object. Okay. So how do we call a member function? So we've already seen that a while ago. Calling a member function requires specifying the object containing the functions. So we do that by using the dot operator. So we've already seen a couple of that in our previous example, but just a review. So again, this is our object, and this is the member function that is being called using the dot operator. And of course, don't forget the argument that is required by this function. So in this case, the open function requires that you provide the file name of the file that will be used as input. So in this case, infile.dat.